Okay, in this video, we will show a demonstration of Texera. My name is Zhuozhi Wang. I'm a public health scientist, and I will use Texera to analyze tweets related to a fire and find and analyze people's sentiment related to a specific fire. So I have two input datasets. The first is tweet. It has the ID of a tweet, the text of a tweet, and the location ID of a tweet. The second dataset, I have a mapping from the location of a tweet to the actual geolocation coordinates of that ID. Okay, so the first thing I will do is to connect these two input datasets using a join. So where I will just drag and drop a hash join and select the left and right input attributes. Okay, so for the next step, I want to find out the distance from a specific fire and to the location of each tweet. But in order to do this, I don't know how to write code. Since I'm a public health scientist, I will invite my friend Yicong Huang, who is a computer scientist, to help me to achieve this. Can you help me with this, Yicong?
Yeah, for sure. Can you share the workflow to me?
Okay, sure. The first thing I will do is I will share with Yicong. I just need to type in his email address, and I will give him write access. Okay, I have shared this workflow.
Okay, let me check. Okay. Yeah, I can see the workflow and your cursor. So from the previous workflow, it seems you're joining the two tables, and now you need to calculate the distance. To do that, we can use some Python code. I'll drag one Python UDF and write the code inside the UDF. Here in the code editor, I can type in the code. Yep. Zhuozhi, can you do one thing for me? For the fire, can you give me the target location, the coordinates of the fire, so we can calculate the distance? Yeah, thank you. The code I've written will process one tuple at a time and calculate the distance between the tuple and the target fire location. That distance will be added to the tuple as the actual column called dist. On the UI, we'll indicate this dist as a new column, and its type is double. I'll name this UDF to be, let's say, calculate distance. To make this UDF running faster, we can use two workers to run the same code in parallel. Now I think the UDF is ready to go.
Okay, thank you. Okay, so next I will add the last operator, which is a filter, since I want to only find the tweets that are within 100 miles of the fire, and I will add the corresponding filter condition here. Okay. All right, since the workflow is finished, we will now run it. Okay, that's great. After we run it, we can see the input and output count of each operator, and we can already see some intermediate result coming from the filter. Okay, so on surface, this workflow looks great. It's running normally, but I just want to make sure that each operator is running correctly by checking its internal state. So I will pause the execution. So now each operator is in a pause state, which makes it easier to investigate. Can you help me to check, Yicong?
Yeah, sure. For example, we can verify the Python UDF. To do so, I can print out some commands to this Python UDF operator. One example here is the operator has the count variable. We see there are two workers of the same operator, and each of them have a different count, meaning they processed the different tuples already. Besides that, we can also check the average distance they have been calculated. They looks correct. And we also can check the current tuple. You see from the return, we there are one tuple for each worker, and they look also correct. So I think everything's good.
Okay, in this case, we can resume it and let it finish. Okay, now the whole execution has finished, and I think everything looks great. Thanks, Yitong, for the help.
Oh, you're welcome.